All right, I'll start. Welcome, everyone. Thank you for joining me today. My name is Laurent Doguin. I work for Couchbase. I'm based in Paris, France. It's my second time speaking here. I think I was here in 2015 talking about Spring Data. So pretty happy to be back 10 years after. And the topic of today is going to be AI agents in the terminal. Because I don't like Python, that's a very personal thing. And that's what drove me to writing my own AI framework with NewShell. But of course, Python's a great language, but it's just not for me. I manage the DevRel team at Couchbase. I also brew beer on my part-time, so if you're ever in France, look for a beer called La Marmotte Masquée. That's what I do. But also, I do tech. Right, so AI agents in the terminal. I'm going to talk about a couple of things first. In the terminal, let's talk about Shell. There's a beautiful project called NewShell, and NewShell is a new breed of shell language. Bash is great. People use ZSH, people use Fish. All those tools are amazing, but I have one problem with them. They're not portable. They don't work the same way on Windows or Mac or Linux. And I come from a strong ops background, and I like to write my shell script only once. And I hate to have to rewrite this for Windows or whatever. So that's why I learned NewShell. And also, NewShell is something we've used at Couchbase to build Couchbase Shell. Couchbase is a database company, and as any modern database, we do vector search, which is great to do AI, so more about this later. We'll do a brief LLM overview, what's a model, and all that, and then we'll talk about agents, and then I'll show you the code and run a demo. So let's talk about Couchbase Shell. First, NewShell, available on newshell.sh, multi-platform, was on Windows, Linux, Mac, available on for your GitHub action, for your Jenkins script, whatever, all those things. What turned Couchbase into NewShell was the fact that anything that's somewhat structured will be managed by NewShell as a data frame. A data frame is basically something that can have table and rows can have names, so it looks a lot like a SQL table or a document, like an XML document or a JSON document. So the moment the CLI tool you're using will output something that's structured, it's going to be automatically managed as a data frame. If it's a data frame, then you can do all sorts of cool stuff that I'll show you afterwards. It supports plugins, it's great, it has rewrite for the basic Unix commands, which is also great because most of the things I use in Bash are not available in Windows, but because of NewShell, well, they did the work, it's already available, so I don't have to rewrite anything. So a simple example, what does ls looks like with NewShell? If you think about a list, there's going to be option, there's going to be the name of the file, there's going to be maybe the size, a bunch of stuff. So if I can execute this and show you, it's a data frame, right? So it outputs a table. There's a name, a type, size, the last modification date. It's a very verbose ls by default. And the good thing about this is because it's a data frame, then you can treat this as such. And so instead of using list, I can use list, and then I can pipe from my list where the size of the document is bigger than 4 kilobytes, and I want to sort them by the latest modification date. So if I retry this again, well, first of all, you see there's less entries in my data frame because I'm filtering by size, so it's only files that have a size more than 4 kilobytes. And then you can see that they've been sorted by the modified date, which is also a date, which is also a native type in NewShell, which is quite cool. So that's NewShell. We took NewShell and we wrapped. We created Couchbase Shell, which is basically a NewShell wrapper. And so Couchbase, being a database, it's a managed database. It works on-prem. It works in the cloud. NewShell will allow you to manage your database instance. So think about NewShell as PSQL, but like better because of the data frame support and all those things. It's written in Rust. Anybody just writing Rust in here today? No? No one's using Rust? That's sad. You should all look into Rust. It's a pretty cool language. And because it's a database wrapper, then you can do all sorts of things. Like, for instance, I'm looking at all the cluster I have that are currently managed by my Couchbase Shell configuration. I can do a list of nodes. So it's pretty small, but this is all the nodes that are in all my cluster. It's a data frame. You can do all sorts of things. And the good thing is you can pipe things through. So for instance, I can open a JSON document. I can put it into a content object, add an ID field, and then I can pipe into doc upsert. And what it's going to do is take that data frame, take that JSON doc, and then it's going to upload it into Couchbase. So this way, when I want to, for instance, turn one of my field into a vector, which is what LLM use, for instance, for search, it's pretty easy to do on the command line. And then you can do all sorts of cool things. You can get the list of index, you can sort them, you can re-upload those index and recreate this in there as a cluster, which is very nice. You can do your bucket scopes and collection creation. If you come from Mongo, that should be very familiar. We store things into bucket scopes and collection. But that's not the most important thing about today. It's also available through GitHub Actions. But anyway, that's Couchbase. If you want to hear more about Couchbase, we have a booth. You can come and talk to us. I'll be happy to take you through all the nice things that we do. But the really important thing here today is let's talk about large language models. Basically, a model is something that understands anything that's been turned into 0 and 1. If you can turn something into 0 and 1, into what we call vectors, then it can understand what it is. If you think about your mobile keyboard, when you type something, there's going to be a prediction of what you type. If there's stupid games like type, create a sentence based on the latest prediction. It's a statistic prediction. Each time you write a text, a message, an email, your phone is learning statistically how much time you use this word or this word or this word. It's not always accurate, but if you keep using it, it's going to look like you're the person that wrote this message because it's statistically using the word that you usually use. A large language model is pretty much this, but on a much, much, much bigger scale. So instead of being just predicting whatever word you might use in your message, it's predicting whatever word comes after whatever suits of words you already had in your prompt. So if I execute this, which you don't see, but I'm going to show you in a minute, how do you call a model? You can self-host model. Most people always use OpenAI, they use Anthropic, they will use any model provider on the internet. It's just a REST API. There is nothing particularly interesting or complicated. And when you learn about all those new frameworks that you have to, keep learning, there's LangChain, there's LangFlow, there's, what's the word? There's the LangChain for Java, there's Llama Index, there's plenty of those, and I always forget the new one. All those things are just basically REST API wrapper that gives you nice nuggets with just a REST call. So what this is doing is calling the OpenAI API, and it's sending an input, which is a text. It's telling me, I want you to use the model called text embedding ADA002, encode this into float, and then you can execute this. And what you get in result is, it's a data frame, so you get an object, it's going to be lots of metadata, but most importantly, you get a float representation, a vector representation of the text that you just sent. So basically, you get an array of a multitude of values between -1 and 1. Those arrays can have lots of different dimensions. If you were to code a color, for instance, color goes from 0 to 255 3 times, so that could be an array of 3 dimensions, because you have 3 different colors, 3 different information to build the colors. That would be a 3-dimensional array. You can have as many dimensions as you want. And what LLM can do is take that vector of numbers and compare it to another vector of numbers it has. And it knows, usually, what is the distance. You can compute the distance between arrays. And the shortest distance means the highest statistic probability that this vector or this word representation is going to quickly come after the other. So the reason we all get into AI is probably because when ChatGPT got out, we are all, like the anthropomorphism aspect of ChatGPT, it felt like we were talking to a human. There is nothing smart about a model. It's purely statistic. Again, it's exactly the same thing as your keyword auto-completion, but like on a much bigger scale. But because it feels human, like we feel like it's somewhat intelligent, but it's really, really, really stupid. It's just math and statistics. But sometimes, if you're statistics, if you're 99% sure that this is going to be the output, then it's a perfectly valid thing. Most of the time, not really. So the way it's been introduced to us by OpenAI and ChatGPT, and pretty much everybody else that copied it from there, we went from a completion system. So you have a system role, an assistant role, and a user role. The system would be the main prompt. A prompt is what you ask a model, and how you configure a model. The system prompt is giving instruction to the model on how it's supposed to answer you. So for instance, you're a helpful bot, and you're going to help me learn about whatever. You always answer me in French because I'm French, or a French answer, that kind of stuff. The assistant role is a little specific. It's the model answering you with other things we'll see later. And then the user role, it's you. It's when you prompt the model, when you ask your question, that's the user role. So they're all basically different messages that are going to turn into a vector and that are going to be understood by the model. So here what I'm doing, which you don't see unfortunately, I'm doing another call, but instead of just turning a string into a vector, I'm sending a message. It's an array of objects. An object has two fields, a role and the content. The content of the role system is your helpful assistant, so that's you explaining to the model how it's supposed to answer you. And then the user is, hey, how can I get out of jail? And then because I'm using NewShell, I'm saving this into a text file. And then it's going to answer something that you don't see because it's been saved into a text file. So I ask the model, how do I get out of jail? I'm going to open my history, and it's going to answer, hello, it's important to report this with blah, blah, blah. So basically, it's a very legal answer. There is no context. Out of the blue, you asked a model that's been taught about the world by reading internet and whatever resources were available on the web. This is how you get out of jail. And then it talks about lawyer, and depending on the country you're in, it takes lots of different questions. It's JSON. Again, all those framework, it's REST and JSON. Nothing complicated about it. Now, what I'm really interested in is I want to open the file that I just saved, turn this into a JSON document, and then get the first message of the choices of answer the model sent me, because model, depending on how complicated they are, can send you different answers. So if I do this, it's going to fail miserably because I made a mistake, but because I'm using NewShell, it actually has a good way of telling you when you do mistakes. A data frame, you get columns, you get rows. Those rows and columns have names. So it can basically know when you're doing a typo. I asked for choices.messages, and you can see in the error that, did you mean message? It knows that message exists because it knows that as a data frame, there's a table, and that the name of the table is called message. So it gives you very, very interesting error message, which is much better than if you were using Bash or any other basic shell. So I removed the S, and there it is. I have the actual message, nicely formatted. This is all the stuff that you could do and you should think about when you want to go in jail. But the thing is, I don't really care about the actual answer. I was just playing Monopoly, and because I'm playing Monopoly, I want to understand how to get out of jail when playing Monopoly. How does it work? A model can only know what it knows. It's been trained in a limited set of data. It has no context. It doesn't know what you're doing. It cannot think. It doesn't know you. So you need to give it context. The way you give context to a model is by giving it a bigger prompt. And the way you can give a bigger prompt is by using retrieval augmented generation. So it's basically turning some data into a vector, so into an array of 0 and 1, and then that's what you would use database for. You would store vectors into a database, and then you will query those database. So the way it works, I have the rule of monopoly as a PDF. So the first command is PDF to text. It's transforming this into a text. Then I'm splitting that text into different rows. Basically, I'm a very lazy person. You should not do that in production, but each time there's a new paragraph, I'm just considering this as a new document. Most people will have much more intricate rules about RAG, about how you split a text into meaningful pieces of content. Like, for instance, titles. Titles are a very significant semantically aspect of your text. Here I don't care, I'm just splitting things by paragraphs. And then for each paragraph, I'm going to generate a random ID. I'm going to insert the document into Couchbase, so that's this line. Then I'm going to create an embedding. So creating an embedding means creating a vectorized version of the text by calling a model, which is the first REST API call I showed you. So again, just an API call. And I'm going to turn it, and then I'm going to put it into Couchbase. And then, if you ask the question again, the answer is completely different. So let me just read that for you. So I upset the document. I create my search index, vector search index using Couchbase. The question is how to get out of jail. I run a vector search that's going to allow me to enrich my question with whatever it finds in Couchbase that was talking about jail. And the answer is, if you want to get out of jail, you need to roll doubles, or you need to get an out of jail for free card, or you need to, pay a fine, which is exactly the rule of monopoly. So it went from being very, very verbose, and this is how you would, call a lawyer, etc., knowing nothing about what I asked. Now it knows about the context. It knows what I asked, and it's basically sending me the right thing, or what I wanted, because I use RAG, because of the database I've been using in Couchbase. I've been able to get my context, turn it into something that a model can understand, which is a vector, lots of vectors, query that, get the important document out, send it to the model, and then get an appropriate answer. And that's pretty simple, actually, just playing with the database and REST APIs. In that context, what are AI agents? So the way it works, you have a simple completion API. You ask a question, the model answer. You ask a question with RAG, the model answer more appropriately. Then you have a chatbot. A chatbot has a different API because it stores the history. And it uses the history just as it would use your RAG. It basically keeps it as context. Then you have another role, which is an assistant, which is basically the model telling you to do things on its behalf, like using a tool or like answering something else, to keep that conversation going. The system prompt is how you configure the model. You use it once, then it's the user prompt. You ask your question, the model answers you with something else. That's the assistant. You answer with something else. That's the user. The assistant answers with something else, etc., etc. So you get a whole conversation. That's chat. If you talk about agents, it's a little bit different. Each time I've been using a chat, I've been the one that's been basically deciding where to go. I'm the user, I ask questions, and it answers me. It's just very simple, one shot. If I ask, what's the example I have here? What's the planet mass of Jupiter, for instance? Multiplied by 2. There's a couple interesting things. First of all, if you ask this question, you must assume that the model has learned what was the size of Jupiter, and that the model has learned how to do math, because I asked it to take the size of Jupiter and multiply it by 2. But the thing is, a model is dumb. It doesn't know math. It just knows that I've read 2 plus 2 equals 4 100 times, so I'm pretty sure 2 plus 2 equals 4. And 2 plus 3 looks a lot like 2 plus 2. So maybe 2 plus 3 equals 4, because I've read that often. That's pretty much how model works. So it's not acceptable to ask a mathematical question to a model, because you're pretty sure it's going to be wrong. So instead of using this, you can use tools. And there were different ways to use tools. At the very beginning of models, there was no specification. MCP did not exist, which is something you might have heard recently. There was no proper tool framework. So you had to have a very custom system prompt that in which you would basically define a way to think about reasoning a problem into smaller tasks based on whatever tools you have at your disposal. It was called the React pattern, reason and action, or TAO for thought, action, and observe. And just let me read you the system prompt. My first prompt was, you're a helpful bot. Very simple. This prompt is much different. It's a system prompt. It says, you run into a loop of thought, action, pause, and observation. At the end of the loop, you output an answer. You thought to describe your thoughts about the question you've been asked. Use action to run one of the actions available to you, then return step pause. Observation will be the result of running these actions. Your available action are calculate, and you give an example of what a calculate operation would be. You get the planet mass, and you give an example of what calling that function would be. And then as an example session, here's a question: what is the mass of Earth times 2? You get a thought that says, I need to find the mass of the Earth. Please call, well, not saying please, but basically it's saying you get planet mass with an argument called Earth, and then pause. And when it pause, it's basically asking you, the developer using the model, to execute get planet mass with Earth, whatever that could be. It's for you to decide. You're the one that is doing the LLM call. So for me, as I'm using a CLI tool, that probably means I'm just going to run another CLI function that returns the mass of Earth. And then you basically answer the model, this is the mass of the Earth. And the model knows that the next, supposedly what you answer is the answer to the question it asks you. And now that it has the mass of the Earth, the other thought is, I need to multiply this by 2. Then it sends you a message that says, please calculate mass of the Earth by 2. And then it's your turn to execute this and then send it back. And then the model will tell you, well, I think that the mass of the Earth is blah, blah, blah. That's how you would do it the old way. And I'm going to show you how it works the new way. The new way is this prompt disappear. So that's what people would use 2 years ago, which is old, admittedly, in the AI space. And now people would use tool. So when you do a REST API call, there's a field for your message, there's a field for which model you want to use, all these options. And there's also a field called tools, which is an array of available function, exactly what I just described, but it's baked in the API of the model. And that's something that every model provider now uses, so it's pretty easy to do. So basically, all the things I've showed you, meaningless. Now we can just use REST API and provide a bunch of tools, which brings me to the code and the things I wanted to show you today. I made my own framework, so I'm going to start by running the demo. So I'm going to run new shell. I'm going to source my code. And I'm going to ask the question, who are the authors of the GitHub project? And that's the project where this is hosted on GitHub. And I'm going to run this, and we'll come back to it, and I'll show you how it's supposed to work. So, what I did was sourcing this file. This is new shell. In new shell, you have modules, which allow you to reference other method or other new shell files, so you can import those methods, which again is something that's that kind of sucks if you want to do it with Bash. And I have different method. I called run. Run is basically, let's instantiate an agent. Here I'm using OpenAI Mini O, which is the latest reasoning model that they have. And then I'm using the run agent method with my query, which is who are the authors of whatever GitHub repo, and then it's going to do a bunch of things. And what it did, because apparently it already worked, is this. So I called run, and then it answers with this thing, which is one of the tools it has at the disposal. I've created tools. So I told the model, you have a tool called Search Internet, and this is how you call Search Internet. You just give it a query. And so here you can see that it used Search Internet, and that it searched for the name of my repo and authors. And it probably give it something. It basically give him a GitHub repository. But the thing is, I also have a method called ask a repository a question. And what that method does is it's basically getting the repo, cloning the repo, extracting the commit log into a text file, a JSON file, turning those into a vector, throwing them into Couchbase, and then it's asking, running that query with the context, with the vector search, and then it's answering, well, this is the person we find that's the author of the GitHub project. How does it work? So I use run agent from agent.new. So let's see. Agent.new. Run agent. Hopefully that's big enough. So to run an agent, the first thing you want to do is get a maximum iteration, because this thing will run into a loop. You don't know how many steps it needs to do an action. And because an agent is, again, just statistic probability, it's very stupid, it doesn't really know when to stop, or you don't know if it's going to stop fast enough. So you could run into a loop, and it could do all sorts of weird things, like consuming lots of token. A token is how you calculate basically the cost of a model. Each time you turn something into a vector, or you basically call a model, you're spending money. You want to make sure that you don't spend too much money, because those can go very quickly. So if you run an agent, you want to make sure that you have limits. So I have a number of iterations, and then I'm calling the agent with my prompt, always storing the history. All of this, by the way, is the new shell language. It's not just a script in your terminal. You can like write a whole script. It's like a Rust REPL in a way. It's very similar to Rust. So it's doing a whole bunch of things. But basically, it's calling the model. So let's go and see what calling a model means. Well, it means it's an API, right? So that's pretty much what calling a model is. I'm using curl because, again, just an API, whatever, nothing complicated. You don't need to use Python or Java or JavaScript or whatever. It's just a bunch of Flask call, so it's simple. It's simple to build your own. The important thing is you need to ask for the right thing, so you need to send the right model. Here I'm saying I want to use the GPT-4o mini model. I have my message history. I have something called model tools, which is the tools that the model will be able to use. And I have two interesting options, stream equal false and temperature equal 0. Stream equal false, when you talk to ChatGPT, it just answers and keep writing. And I'm using a CLI. I don't really care about this. I just want the answer. So I deactivate the streaming, just answer. And temperature equals 0. Temperature will be a number between 0 and 1. And it's basically asking your model how to be creative. If you think about how model and statistic works, it's a neural net, but it's a very, very big neural net. Neural nets were modeled after our brain. If I ask you a question, your train of thought is going to be something simple. It's going to be something. If I ask you the exact same question to someone else, or to you, but like 2 minutes after or a day after, your train of thought's going to be different. The answer is probably going to be exactly the same, but we don't always take the exact same route between all our synapses and everything. A neural net works the same way. If you ask a question, a neural net has different paths to get to that answer. The temperature is basically how it's a metric that allows you to say if it's 0, always take this very specific path. It's not going to be creative. It's basically getting a consistent answer, which is what we want because we always want to have the same sort of result. And so it has a thing called model tools. So if I look at model tools come from tool library. It's in my folder called tools. So let's take a look at tools. And this is tools library, which is basically a JSON array. And it has a function. It has several functions, actually. The first function is calculate mathematical expression. That's the one I talked about earlier. It has a function called get planet mass. That was my example. It has a function called import a Git repository. It has a description. This function will take a Git repository URL, clone the repository, and extract the commit log and import it into a database. And then, basically all I told you is going to vectorize your commit log. You have to be very thorough in your description of your function because when you send that to a model, that's how the model reasons. It knows all the description. It knows what it can do. So if you're not very, very thorough in how you describe what your function is going to do, it's going to be different. It's not going to work, probably. So the description is super important, and then you have the parameter and the name of the function, which is something that is mostly related to whatever you're building. For me, it has a parameter called repo path and repo name. There's a function called think code, which is not going to be used today. And there's a function called ask repository, which is it takes a Git repository name and it runs a vector search. So it basically does RAG on the repo that's been imported previously. And then there's the search internet function, which just uses DuckDuckGo. So this function, when the model answers me, it answers me, well, please execute that function. If you're using Python, it's going to be a Python library, it's going to be a Python method. I'm using a new shell, so it's just a new shell method. So this is calculate, this is how you get a planet math. This is how you search the internet. For my specific implementation, search the internet is using another command line tool called DDGR, which is DuckDuckGo with a JSON output. If it's a JSON output, it's a data frame. I can manipulate it through a new shell. I can do all sorts of cool things. So I can get an answer. You get the idea. And then import repo and ask repo are using Couchbase shell. So it's in there. And so what you can see here is how do you do a vector search query with Couchbase? With Couchbase shell, it's pretty easy. You get the name of the repo, which is the name of the collection where I've stored all my repo vectors. And then you have a question. So the first thing you do is you turn this question into a vector. So you have your array of values between 0 and 1 that you can then pipe into another method called vector search that will take the name of the repo because that's the name of the index, a field. You ask for the 10 closest results, and then you do a bunch of selection. You remove some things. Basically, you get whatever you wanted. You get the content that's interesting for you, and then you can pipe it into a command called ask, which is basically going to call a model by using whatever you piped into that model as context, so as RAG. And it works because this is how I import a repo. It's basically a Git clone, and then I have a function that extract my Git log, put this into Couchbase, run queries. There's a bunch of code. It's not super important, but basically you can do all these things. And how it translates into is I've logged all those calls, all those API answers into different files. So the first time I asked the model who's the author, it reasoned and answered with the following message. There was no message except something called tool calls, which you see here, which has an ID, and is basically a function, and it's returning search internet with this argument. So that basically tells me this is what I can run on my machine. This is what you could run by using any code, any framework. It's just basically asking me to call the search internet function that I showed you earlier with those parameters. And as an ID. So when I answer back to the model, when I answer back to the assistant, I can answer with the ID of the function and the actual answer. And the next step is going to be apparently the same thing, because it didn't work the first time, which is why you should always have a loop that iterates into those kind of things. And the other function is ask repo, so it's doing all the thing I just showed you earlier. And then the last thing is not a tool call, it's the actual answer. And here you have a finished reason called stop, which is when you know how to exit that loop before you've looped over. So it's basically just a bunch of chain call, a bunch of chain REST calls. There is nothing magical about doing AI stuff, which would explain why there's one new framework every 2 months, and why everybody's doing AI in a couple years. It's super easy to do, and I invite you all to try and do that kind of things on yourself. It's very simple. So if I go back to my demo, maybe someone in the audience can tell me, do you have a GitHub repo? You, or you, or you? Anybody has a GitHub repo? Do you want to come and type it in? And then we can do the... If you can just do organization/repo name. And that's a US keyboard, so that sucks. Should be this. Is that what you wanted? Yeah. That's it? That's an existing repo? Okay, let's go. So you can see that it's cloning the repo. I previously run my example, so it's not fun. This is a new repo, so it's actually cloning the repo into a new folder. So calling my tools. Which you can see here. Import git repo, so it's doing its thing. I have the repo. Do I have the repo? Not yet. Still cloning. Hopefully you don't have too many messages in that, too many commit messages, because that's going to be fun and long. It extracted everything into a commit log. So that's also my tool doing this. It could be your code, could be my code, could be an MCP server for, and so I have the list of all the messages, and now it's turning everything here into vector, and that's going to be a lot of vectors, so it might take some time, but we'll see. Do you have any question in the meantime? Because there's really nothing else to it. This is what an agent using tool can be. This is not as agentic as you could be. You start to see projects that have agents that supervise other agents. So basically, you're using a model to do the reasoning, and then ask the question. Some other model will do what I just showed you, the reasoning, send the answer back to that model, and that model will assess if it's an acceptable answer or not. And if it is, that's great. If it's not, it's gonna, reloop to some other model. So it's basically taking the reasoning out of you and giving it to the model. So what we did with AI agent is putting more deterministic approach to a probabilistic approach. When you do something with model, it's just the answer is going to be statistic based. So you're not sure it's going to be true, which is why we're building agent, because agent is your code, and usually the code that we write is deterministic. It's something that we control. So in a way, we've been putting bad code into AI because AI doesn't always work. You cannot trust AI to do some sort of operation. You cannot trust AI to do math. You cannot trust AI to do something deterministic that it does learn statistically. There was probably too many comments. You have a smaller one? We can try a smaller one. Or we can, I don't know, we can wait. I'm going to do another one then. I'm a dev, so of course I only do like small demos. So of course all my repo are very, very, very small. So it's easier. And also my laptop is not working for some reason. Do you have any questions in the meantime? Anything you want to know, anything that wasn't clear, anything? There's a microphone right there. If you raise your hands, you'll have the mic and you'll be able to ask anything, about anything. You can ask questions about the beer, you can ask questions about Couchbase, you can ask questions about agents, model. Question over there.
Hello.
Hello.
So how does your method differ from using MCP, or does it really differ? And what are the advantages or the handicaps?
Okay, so that's a good question. I've created this before MCP showed up. MCP is still pretty new. And I've created this as a way to learn how this works. I would discourage anyone to use this in production. The moment you let your terminal run any function on your behalf without a yes or no, do you want to execute this, will lead to terrible things. There was a researcher in security that started doing this, and he basically asked the model, it gives the tool every CLI tool it had on his system, and he asked, please update my system. It was inside a VM, and he thought it was safe. But VM has a way to go outside of the VM. So basically, please update the VM. The model answered, being very nice, I don't know how to update the VM, but this is what you could do. And because he had a way to automatically execute everything, he was just doing everything that the model was telling him to do, and there was no maximum iteration. So the model found a way to exit the VM, to go to his actual system, to then update his actual system, but didn't update the bootloader, so he borked his machine by using this. The main problem of all those things is not going to be how hard it is, because as you can see, it's actually pretty simple. The whole problem about all those things is going to be, how do you integrate something that runs things automatically to a system if you think about security and governance? Because that's hard. Like what you expect from an agent system is to do things automatically. The moment you do things automatically, well, you're either very, very paranoid, which is what I probably would advise you to do in a production setting, and only allow the agents to do a very specific substep of things. But then if you can, really filter down the amount of actions or the kind of action it can do, then let's be frank, it's not going to do much that you cannot program yourself. It becomes interesting if you let him do creative stuff. But the moment you do that, you start having governance and security issues. We had the same problem 15 years ago when we started doing workflows. Workflows are older than that, but at the time that's what I was doing. I was doing workflow. The goal of a workflow was very similar to agents. Agents, you'll code all the steps. That's the agent, the tools. And then you give the reasoning, so the routing of the workflow to the agent. The agent, the model decides which step to call after the other. When I was doing workflows, I was coding this. But the problem I had going to big companies opening those workflows was each time you had to go from one step to the other, someone had to actually validate and click on a button so that this thing actually happened, because that's how it was. The governance model of the company, the security model of the company, required someone to actually, click on something. So the value of this becomes a lot less interesting. Now, the good thing about MCP is that baked in MCP, you have auto-discovery of MCP servers. And auto-discovery is pretty cool because, well, there's so many things you can ask, even things you don't know yet. And so when people will add MCP server, think of an MCP server as a tool that's available through an API. It's basically what it is. Well, the world is your oyster. You can do so many different things. Do you want to do so many different things automatically? I don't know. All right, so apparently it worked, because it was much smaller. And it's saying, yeah, the author of Coverage Java Importer, which it's me. So yeah, tools work. Woohoo! Yeah, that was my demo. I think I'm done. Unless we have any other question, I will let you go on a break. And if not, I will
Soru var
thank
mı
you.
acaba? Tamamdır, Özgür.
It can be a little discouraging, but it's going to be amazing once AI is much safer than what it is today. I'm not saying you shouldn't do AI, like I'm being a little bit negative about these things, but there's going to be a moment where most of those problems are going to be easier to solve, and AI is going to be closer to deterministic behavior than a probabilistic behavior once we've trained all those models with much more data and much more compute and much more power. But that's not today, that's maybe tomorrow, so we'll see.
Thank you very much, Lord.
Thank you. Cheers.
Çıkmadan ben hızlıca bir şey